Hello everyone. In this video, we are going to discuss how to design a machine learning system which involves large language model. The purpose of this video is that how to effectively design a machine learning system and also to illustrate that how you can structure your response in a real interview. So let's get started. So first of all, whenever you go to the interview, you will get certain requirements from the interviewer. For the purpose of this video, let's consider that the requirement is as given. For the company XYZ, we need to design a chat system that can handle customer service queries and tries to resolve them automatically. For example, there is a company XYZ and it has a customer service human employees who would try to resolve questions coming in real time from the users. What we need to do is we need to design a chat system using large language model which can automatically answer those user queries for us, and it should do as effective as it can. Now you will only be given this requirement in the interview. Your job is to ask some clarifying questions. You can ask like, do we have any past history or previous data that we can use to train the model? What is the business objective of designing this system, etc. Now let's consider that we asked these questions and we found out that these are the provided details along with the original requirement. We are given a past chat logs between customers and the customer service human agents. Also, we are given a small data set for document retrieval. So the use case is that we might need to refer some internal company documents to answer user queries. To do that, we are given a small data set containing a user query and corresponding ground truth documents which will be used for RAG system. So our requirement is to fine-tune large language model and evaluate it, and not just evaluate it once, but we need to incrementally fine-tune and do continuous evaluation on this model. And we don't just need to design this large language model, but we also need to integrate certain tools with it. We need to integrate RAG data store, which would help us if we want to look our answer into certain documents. We might also need to call APIs to answer the questions from the customer. And we might also need to query SQL or NoSQL DB. So these are the requirements. So let's design this system. We will start with initial modeling. First, we will choose a large language model which is already available in the open source. For the purpose of this video, we are choosing Llama 3 70B with 32,000 context length. In the real interview, you will have to justify why you want to use this particular model with this particular size and this particular context length. You can probably say that our use case is complex enough, which might not be solved by smaller size Llama model, which is Llama 8B or Llama 14B. And we do not even need to answer any general query which is augmented by internet. And that's why we might not require very large size model, which is Llama 400B. And that's why we have selected Llama 70B. So the first step is to do supervised fine-tuning of this Llama 3 model. To do that, we will use the past chat logs that we have as part of our requirements. So what we will do is we will fine-tune our model on those past chat logs. The model will be trained similar to how we pre-train the model, which is next token prediction. We will provide user prompt and will ask the model to predict a token in the customer service agent's response. This is called instruction tuning of the model. Note that we might need to use lower learning rate for SFT because the model is already pre-trained. We can use LoRa adapters, which is low rank adaptation technique, for faster fine-tuning and then merge the weights at the end. If you're not familiar with this LoRa technique, then I would highly suggest you to look at it. Once we are done with SFT, we might also need to do alignment. Now, alignment is the process with which we make the model more aligned with human values so that it answers in appropriate language and has certain level of humility. For alignment, there are various different algorithms with which we can align our model. For example, PPO, which is proximal policy optimization, DPO, which is direct preference optimization, IPO, which is identity preference optimization, and KTO is Kan-Tversky optimization. You also need to mention which algorithm you want to use and why. So you can mention that PPO is the best choice, but it is expensive to do, and KTO is less efficient for the first time alignment. So that's why we can use DPO or IPO, which is essentially the same with slight modification. For alignment, we can manually create pairs of responses and force the model to classify which one is better. For example, we can have a user prompt and we can take this from the past chat log data that we have. Then we can generate the response from the SFT llama that we have trained as response 1, and then we can generate response 2 using more powerful language model like GPT-4 or ChatGPT, and we can put it as a response 2, and then we can force the model to classify response 2 as a better answer than response 1, and this way the model will get aligned towards generating responses like GPT-4. Moving on to the second part of this initial modeling section, we also need to design an embedding encoder model. This will be used for RAG use case that we have. To retrieve the documents from the vector database, we need to reference a key. A key would be an embedding of the query that the user passes. Now, how would we build such embeddings? So there are two ways of doing this. The first way is that we use already built embeddings like OpenAI's text embedding ADA or Cohere's embed v3 or already trained sentence transformer embeddings. But the better option is that we train our own embedding encoder. What this will help is that the encoder model understands the underlying data that we have, and that's why it will be better as compared to using some already trained embedding models. For the purpose of this use case, we will choose sentence BERT to fine tune on our data. Now, what is our data? So our data can be documents or internal reports or some books that we have which has the context of the domain in which company is operating. So we can fine tune our sentence BERT model on those type of documents. What objectives this sentence BERT model would be trained against? So the first objective is MLM, which is masked language modeling, and the other objective is contrastive loss, which is next sentence matching or next sentence prediction. If you want to understand in depth about MLM and contrastive loss, please comment down and I'll create a separate video for that. You can also mention some details like masked language modeling is easy to do with self-supervised learning, but for contrastive loss, we need to do some heuristic pair creation for two sentences, and that we can do in batch, or we can dynamically generate pairs of sentences heuristically as well. But all of these can be done in a self-supervised way. We do not need any external supervised data set created. Once we have a good sentence BERT model with which we can encode our documents, now how do we store these documents in form of embeddings in the vector database? We can do that using document chunking. So we can use LangChain's semantic chunker to chunk the documents into pieces, and each of those chunks would represent the same semantic meaning, and that's why this will create semantically extractable embeddings. Now we can store these embeddings which we have created from our documents in some vector database store. There can be many different vector database stores like Viviet, Pinecone or ChromaDB. For this use case, let's take Pinecone to store the embeddings. Now, once we have stored the embeddings, we also need to create another model, which is a re-ranker. This can be pure deep learning model, which takes the pair query and the documents and returns probability score for relevancy. So let's say a user has passed some query and then we have extracted some k number of documents from our vector database. Now what we'll do is like we will take query and each of those documents, and then we will use this model to predict a probability score for relevancy, how relevant this query is to this document. We would rank the documents in a descending order of the probability score. So this is how re-ranker works, and you can find many blogs on the internet on why re-ranker is required in very large RAG system. The simplest reason is that the documents are so many with respect to query, so that we require the re-ranker to rank the documents such that the most important or most relevant document is on the top. So that's about initial modeling. Now let's get into the system and let's integrate all these components to create the entire chat LLM system. Right now this system is looking very complicated, but wait for a few minutes, this will start getting more clear and clear. Initially, a particular user would send a prompt to this system. Now, what we will do with this user and prompt pair is that we will get the past chat history for that particular user. What this means is this prompt which user is currently sending might not be the first prompt which user is sending. There might be some past chat history of user and our chat system. So that's what we want to fetch from this chat store. What this chat store service would do is that once the user has sent some prompt, the chat store would get the past chat history of this particular user with the chat system. It will send it to the planner. The planner will take the chat history, the current prompt, and the planning prompt template. Now, what is this planning prompt template is? So we want to plan some tasks for this particular user so that we can resolve their queries. That's why we have created a prompt template that contains all the examples and all the instructions that our LLM needs to follow. And that's why we have a planning prompt template. What we will do is we will integrate our current prompt and the past chat history into our planning prompt template, and then we will create a planned query. Now, how would this planned query look like? So the planned query will look something like this, where we assign a system prompt like you are a helpful assistant and blah blah blah. We instruct the LLM that you are provided access to tools, relevant past chat history, and the documents. You need to use different tools as described below, and then you can describe different tools you have in your chat system. Like for example, use SQL tool when, and you can provide the situations when SQL tool would be useful. Similarly, you can mention use docstore tool, which is our RAG tool, when, and you can also provide the situations here. You can also provide the examples of the situations when a particular tool would be useful. Later, you can also provide the chat history. So here you can provide a chat history of the user and our chat LLM system, and this chat history is taken from the chat store. After that, we provide the current prompt, which is user, and then the current prompt that the user currently has passed. We will mention it here. And at the end, we will provide agent scratchpad. For example, when LLM needs to calculate something or LLM needs to figure out or plan something, they would write their notes over here. After this, there is a React service. Now, what is React? So there is a famous paper from Google. It is called Reasoning with Action. What this enables is that now our LLM model is not just answering bunch of questions, but it is also capable of acting based on it. So basically what it will do is it will first reason about the question and then it would act upon it. So what this React would do is that it would take this prompt and then it will take a look at tool use cases and it will take a look at the user prompts and then it will reason about it first. And after reasoning about it, it will follow some action. Following some action can mean either using SQL tool or using docstore tool or using some other tool. And that's what action means. The React service will reason about things and then it will take action. And all of these reasoning and action notes, it will write in the agent scratchpad. Let's say, for example, the React service decided that I want to take action to call an SQL agent. SQL agent is basically this SQL tool that we mentioned in our prompt. SQL agent is particularly specialized in generating SQL queries. So what happens is, let's say our React service wants to know that how many people work in our organization, and that can be efficiently done using the SQL tool, which is we create an SQL query first, then we execute SQL query in our database, and then we find them some answer and we curate a natural language answer based on that query response. And that's what entire SQL tool would do. SQL agent has a few short query template. Now, what is few short query template? So we have already written a database and table schema in our prompt, and then based on that we have written some example queries which LLM can take help of. So based on those example queries, LLM would generate query from the prompt passed by the React service. Once the query is created, we will validate the query and correct the query. Sometimes what happens is that there would be some spelling mistakes or reference mistakes in the generated query. So we have to validate the query and then correct it if there are any mistakes. For this query validation process, we will use query validation or correction template. You can think of this template as bunch of rules written about query validation. For example, the query whichever we generate cannot be delete or drop query. It can only be select query, etc. Once we have generated a good query, we need to execute the query into our database. For this, we can create a separate service which would just execute this query onto our database. Once the query is executed and we get the response from the database, we will pass that to our LLM, and this LLM would curate a natural natural language answer. For example, if we have asked how many employees are working in our company and it gave some response in terms of list and tuples, then this LLM would take that response and create a natural language answer based on that. Once this answer is created, it will pass it to the React service again, and then React service would append that answer into the agent scratchpad and then reason it again whether the final answer for this user prompt has been found, or do we need to use any other tools as well. So let's say, for example, we need to use this doc store agent, which is our RAG system. We need to find some answer in some internal company documents or reports. So in that case, the React service would pass the prompt details into the doc store agent. What this doc store agent would do is it would use another prompt template, which is RAG prompt. You can use a very famous RAG prompt from LangChain Hub to retrieve documents from the vector database. The doc store agent, similar to the SQL tool, would also integrate the information passed from React service to the RAG prompt, and then it will encode this entire prompt into an embedding, and then it would find the similar embeddings into our vector store. So for this use case, we are using Pinecone database, and that's why it would find most relevant documents for our prompt in this Pinecone database. Once we find, let's say, top K or let's say top 10 most relevant documents, we would re-rank it using our re-ranker model that we talked about, and the ranked list would be passed to the doc store agent again to find the answer. Now what doc store agent would do again is that it would take the original RAG prompt that we have generated, it will append all these document metadata to that prompt, and then it will call the LLM again to find the answer from these documents that we have retrieved. And based on those documents, the LLM would curate the answer and send back to the React service. Now this is the overall system that we have talked about. I hope now it would make sense to look at the entire system easily. Note that you can also add as many such tools as you want. You can also add the math tool, which is LLM math from Llama Hub. You can also add API calling tool, or you can build one using LangChain, and so on. So this is the entire system. Now you might have seen that I've mentioned here R2, R3 and R1 here. So what are those? So these are the responses that we want to evaluate. Once we generate the SQL query and the answers from it, we want to evaluate that. So that is R2. We want to evaluate our responses generated by this RAG agent, which is doc store agent. We want to evaluate that as well. And we want to evaluate our main answer, which is generated basically from the React service. We also want to evaluate that. We need to mention some metrics with which we will evaluate this R1, R2 and R3. Let's take a look at evaluation process then. So for evaluation, as we mentioned, there are three things we want to evaluate: R3, R2 and R1. R3, if you look at this one, so the R3 is related to RAG, R2 is related to SQL agent, and the R1 is related to the overall system evaluation. So that's why R3, which is related to RAG, we need to evaluate three things here. One is recall, how much the retrieval capability of the system is; ranking, what is the ranking capability of the system is; and the relevance, how relevant documents do we extract to answer the user prompt. For recall related metrics, we can calculate context precision, context recall, and context entity recall. For ranking, we can calculate AUC, mean reciprocal rank, and NDCG, which is normalized discounted cumulative gain factor. For relevance, we can calculate answer relevancy and faithfulness metrics for the generated answer. Moving on to R2, for R2, we can calculate the metrics related to the example selector. So here we have a few short query prompt. We will provide some few short examples to this SQL agents to generate the query. But to generate the query, it will select some examples which are most relevant to our given prompt. So we need to evaluate which examples are being selected. To evaluate that, we can check precision, recall, and top 1 accuracy of the selected examples. We can also evaluate the execution accuracy. For example, we generate the SQL query, how many times this generated SQL query is successfully executed into our database and how many times it gives error. We can also track this, which will help in future to improve our execution capability. And the last is evaluating R1. Evaluating R1 is directly proportional to evaluating the planning capability of the overall system. And to do that, we can use multi-agent peer reviews. So basically, we can use multiple AI agents to evaluate our planning of solving the task, and then we take the majority vote among those AI agents to decide whether our system is doing well or not. Now, if you want to understand in depth about these evaluation metrics, then I would strongly suggest to look at the RAGAS framework to evaluate the RAG based systems, or else you can also comment down and I will create a separate video to discuss the evaluation metrics. Moving on, so the above evaluation metrics were the first time evaluation. Whenever we create the entire system for the first time, we will evaluate these things. But how do we incrementally improve our model? So there are basically two types of incremental aspects that we can think of, and these are both related to the users. How can a user who is using this LLM system can provide the feedback to us? So there are two types of feedbacks that we can discuss. The first feedback, which is F1, is that thumbs up or down. Once we generate our answer, we would provide the user the capability to either click thumbs up or down. It means it is similar to how we use the ChatGPT tool. Like if we have found the answer generated by chat system helpful, then we would click thumbs up or we will click thumbs down. And if the user clicks thumbs down, then we will store this entire conversation into our evaluation database, with which we will fine tune our model, and we will redirect that user to a human agent for solving their problem. So this is the first type of feedback that we would get. The second type of feedback is directly related to whether the model is generating appropriate responses or not. The user can report generated response, and this report is for when the model generates inappropriate language, words or tone. If the model is generating response which has like an angry tone, or if it has inappropriate language, in these cases the user can report the generated response, and we would use these generated response to fine tune or align our model. So the F1 helps in improving recall context capability. It means for the RAG use case, we want to improve the retrieval capability, the generation capability using LLM fine tuning and embedded fine tuning. So we can fine tune our embedding encoder and the LLM using this feedback 1, and this feedback 2 helps in improving the safety by aligning the model more towards human responses. And we can use the KTO algorithm to align, because now we have good or bad responses labeled. The user has reported certain response, then it means it is a bad response, and if the user doesn't report anything, it means it is a good response. So we have this binary classification sort of responses, and at that time we can use the KTO algorithm to align automatically. Now at last, we have some important details that you might want to mention to the interviewer. So first thing is, we want to enable quantization. So we can enable layer wise quantization so that the inference latency for the model would be extremely less, and we would be able to generate the entire natural language answer very fast. Now what should be the decoding scheme for the LLM? So as of now, the most popular decoding scheme is this hybrid scheme with top K and top P, where we would select the top K tokens at each step, and then from those K tokens which we have selected, we will select top P tokens which has like overall cumulative probability P. In future, we can also explore some fancy decoding schemes like speculative decoding as well. The overall chat system should use LangChain for chaining and redirecting responses to various tools. So for example, we have a React service. So how do we redirect the response from the React service to SQL agent or to a Dockstore agent? So we can use LangChain for that. We can also use existing prompt templates which are provided in the LangChain hub, and we can customize them as per our use case. At last, we can also use common task agents like math agent, which is LLM math, or some general question answering agent, and these type of common task agents can be found in Llama hub, and you can directly use them as it is. So this is the entire system which we have built, and we have covered almost all the aspects. I hope you have found this video useful and insightful, and I hope it will help you in your interview preparation. Please comment down what you want to watch next. I'll be happy to create the video on that topic. Thanks for watching and stay safe.